Hello everyone. Welcome back to the hands-on session of CNN. In the previous lecture, we have discussed the theoretical aspect of artificial neural network. In that, we have seen that how ANN works, and at the end of that lecture, I have briefly discussed the CNN. In today's session, what we will do, we will try to implement CNN over our own data sets. That is, we are not going to use the existing database or existing trained model to apply CNN. And let me briefly discuss the things that I have discussed in the previous lecture. Then I will discuss the agenda for today's lecture, and we will proceed further. So, we have discussed this part, that is your fully connected layer, in the previous lecture. And in that, we have seen how the value of the weighting coefficient updated in every pass, that is your every epoch. I will discuss the difference between iteration and epoch at the end of this lecture. So what we will learn today, we will learn this part. So uh, provided an image, so if you have a given an image, and you are asked to create a CNN over that image for classification purpose, then you need to apply convolution. Then you have to add non-linear input, means you have to add some non-linearity. It is basically called non-linear layer, and then pooling. So we will what we will do, we will apply these things again, these things, and again these things. So I have discussed what pooling is. Pooling is basically to summarize the data into a lesser memory, which is just to save the uh, computational space and make it computationally efficient. So let us start by doing it. And this complete process that is highlighted in black is called feature extraction. And what we will do in today's lecture, that we will define three classes based on the land cover of ISER Bhopal itself. And in ISER Bhopal, we can broadly classify the land covers into built up, open land, and vegetation. So what we will do, we will train a CNN model using several images falling under built up land, open land, and vegetation. Once our model is trained, then what we will do, we will provide a new image, a completely new image, and check whether our trained model will able to classify them correctly or not. So this is mainly a classification task. So before we proceed further, what we have to do, we have to do two things. One is to create the data for training, and then create a feature extraction step for our CNN model. So what we have done, the images that we have selected for classification purpose is your image taken from Google Earth. So let us go. What I have done, I have taken the images from the Google Earth web page. Google, sorry, Google Earth, and that Google Earth Web. So the main challenging task while using CNN is to create our own train network. So it is very difficult, not difficult exactly, but it is very the first thing that people want to know how we will train our CNN model over our own set of data. That is the challenging part. Otherwise, there are various trained model that are available in the market that this model is trained over these sets of data. But since we are working with remote sensing images, so we have different sets of images from different satellites, and we have different research objectives. So to meet them, we need to learn how we are going to train the CNN model over our own set of data. So let me go to the Bhopal. Let me zoom it. This is Bhauri, and this is our ISER. So you can see this is your hostel one. This is IWD. This is your lecture hall. Yes, that is your ensemble. And what we will do, we will take images from this Google Earth page and train these images based upon the category it lies. So we have selected three categories over ICER. One is built up. This type of things comes under built up. And second is open land, means this is an open land. This is open land. And if you can zoom that, this part I have considered as a vegetation part. So let us start by uh, means preparing our own set of data. So before proceeding further, you have to decide what will be your what will be the size of the training images. So if you are going to select image of size 100 cross 100 pixel, then you have to be consistent. Means suppose you have selected 50 images of built up, 50 images of your open land, and 50 images of your vegetation, then all these 150 images will have the same spatial resolution, and it should have a dimension of 100 cross 100. So let me show how I have done the things. There are different ways to do so, but I will suggest, since you are a new learner, so I will also share the way that that you can apply later on. But for starting the things from the scratch, just suppose you are interested in taking this image as a built up. So just take a print screen of it, open the paint part, paste that print screen, select the select item tool, and select this part, and then click on the crop button. So you will get that desired image. So if you see, the size of this image is 185 cross 157, but you have to be consistent with the resolution or the size of the image. So you need to resize. You can resize it from the paint itself, or there are several inbuilt command in Matlab through which we can resize these images. So I will suggest you to just first use the inbuilt as not the command. Just select correct it from the paint itself. Just put the 90 cross 90. So the pixels should be 90 cross 90, and just click on OK. So this is your final images. So let me save it. Let me create a folder in this ES338. Let me create a folder called images for CNN. In that folder, let me create some subfolders. That is, this image is for build up. So let me save that in this folder B1. Okay, and similarly, what I will do, I will take some vegetation images. This image is, I guess, sufficient. Just take a print screen, go to the paint, create a new file, paste it, click on the select button. While selecting your images, just be means very precise. Means you have to avoid built up while selecting image for vegetation, or you have to be very careful to select the built up area, so that there should not be any open land or built vegetation should be there, because it will ultimately confuse your model. So I have selected this region. Let me click on the crop part. Let me resize it. And 90 cross 90. Okay. Let me save it. Let me create another subfolder with the name vegetation. And let me save it in this part, V1. And let me take a open land example. So this is your, I guess, just take a print screen of it. Just click on the select button, select a part, go to the resize button. Yes. Oh, I have, sorry. I have let me create a new file. Okay. I have to correct that vegetation image part. That we will do. Let me create another folder with the name open land. And let me save it here with the name O1. Let me correct that vegetation part. So what we have done, let me go to that image part, ES338. That is ES336, and in that images for CNN. So we have created three classes for ICER Bhopal. That is your built up open land vegetation, and we have now we have taken only one images. So similarly, what you have to do, you can take 10 images or 20 images for built up, or 20 images for vegetation, or 20 images for open land. So once you done this part, and this part I have already done. So let me show you the things that I have already done for you. Yeah, in this train CNN part, what I have done, I have taken 10 images of built up, 10 images of open land, 10 images of vegetation from the ICER Bhopal campus itself. And all these images have a dimension of 90 cross 90. You can just put the cursor, you can see 90 cross 90, 90 cross 90, and so on. So after you are done with your data, so the remaining part is to write the code in Matlab. So for writing the code in Matlab, we have, let me close the unnecessary part. So let me clear everything. So you can write the code, means you can create your own CNN network by two means. The first approach is to write the code directly in the MATLAB script, or the other step is to use the built-in GUI, graphical user interface, provided by your MATLAB. So what I will recommend to you, since you are means initial learner, so just start with GUI, and then means transfer your learning to the start writing the code in the MATLAB script itself. So let us wait to get everything cleared up. Yeah, it's done. So what you have to do, just go to the app, and in app we have different GUIs available. You have to select deep network designer. It is app that MATLAB provide to create your own CNN, over means to train your own CNN network for your own set of data, either for classification purpose, either for regression purpose. So let us wait. It may take some time to open. So meanwhile, what we can do, we can just go to this part. Yeah, so we are done with this part. We have now the input images. Now what we have to do, we have to create this feature extraction part, and once we are done with the feature extraction part, then the rest things are very easy. And in this example also, what they have done, they have classified the things in three different classes. And similarly, what we are doing, we are just classifying the things in either built up, either open land or vegetation. So I guess it has opened. So on opening the deep network designer, this is the interface that you will encounter. So there are some pretend network that are already available for you. In the last lecture, I have told you about Google Net. It has a depth, means the depth is that number of hidden layer. It is 22. The size I have already mentioned. And for using Google Net, the size of the image input should be 244 cross 244 cross 3. Cross 3 is your RGB band. So in suppose the main task is that since if we are working with RGB image right now, so we have three bands, that is your RGB. But suppose you are supposed to work with Landsat 8 or Landsat 5, then there are many bands. So suppose you are interested in selecting 5 bands and start working on that. So these things you have to customize your own. So I will tell you how you will customize the number of bands and the size of the image input. In our case, we have to select the input images of 90 cross 90 cross 3 for RGB band. So let us first create a blank network. We will going to create our own CNN network over our own data. So for that, it is a very user-friendly GUI, and we will not implement everything in this GUI. What we will do, we will just do the feature extraction part. Once the feature extraction part is done, we will switch to the MATLAB script part. So let us you do the things with this CNN network. So for input images, what we have to do, we have to create a input image input layer. Just drag it. You need to just drag it and just click on this designer page. It's done. The second layer is convolutional layer, followed by a rectified linear unit, and then followed by a pooling. So let us do the things. Let us select a convolution 2D layer. For image, it is 2D layer. Then we have to select some non-linear function, and that is a rectified linear unit, followed by a pooling. And in pooling, we will select max pooling. There are different types of pooling algorithms: average pooling, global average pooling, max pooling, and so on. You need to just explore the things. So we are done with this red circle. So we can repeat these things any number of time. Here it is repeated 3 times. You can, if you are interested in learning some more features, so you have to increase this part. But since we have very simple task that we need to classify the things, and that too in only 3 classes, so what I will suggest, just use only tool part, just use only 2 feature maps. So let us go back here and again select the convolution layer, rectified linear unit, and maximum pooling. So instead of selecting that, I will just copy it and paste it. Once we are done, we need to add a fully connected layer. Before fully connected layer, there is a flatter layer, but in case of images, and especially if you are working in MATLAB, this flatter layer is not required. But if you are working in with video images, that you are training with video images, then you have to put flatter layer for sequence images. So we can skip this part and directly put a fully connected layer. Let us go back into the GUI and search it here, fully connected layer. Just drag it. After that, we have soft max followed by a classification task. So just write soft max, yes, with the classification output, classification layer. So this much layer you need for feature extraction. So before we proceed further, you need to connect these layers. For connecting, you just have to click on this and just connect it. Just ignore the way the arrow get connected. It should be connected, but so once we connect the things, then the first thing is to analyze your feature space, so that it will troubleshoot and let you know if you have done any mistake. So just click on the analyze button and you have to wait for a couple of seconds. So it will show you if you have done any mistake in selecting the layers. It may take more time in the lab PC. Yeah, here you can get the summary that the total layer is 10. We don't have any warning, we don't have any error. So this is a short layer diagram that convolution layer, rectified linear unit, maximum pooling. Again, the same thing is repeated with a fully connected layer followed by a softmax layer and then the classified output. And here is summary and the type of input. But here you can see this network is available only for the images of dimension 2 to 7 rows, 2 to 7 columns with 3 bands of RGB. So what we have to do, we have to change these things before exporting the code. Just click on this part, go to the input size. Since we have prepared our image with the dimension 90 cross 90 into 3 for 3 RGB band, just mentioned it 90 comma 90 comma 3, and the total number of classes that we have selected is 3. We have to also correct that part in the classified output. So just before that you have to do some more thing, that normalization you have to select it to, means you can change any, you can select anyone, and dimension auto, it's okay. And just export it. Now what we are doing, we are just switching from the GUI to the MATLAB script. And for that let me let me select the MATLAB directory where we have to export this code. Let me select that part only, that is ES338 and at 336. and images for CNN. Okay, so once we click on the export button, there are three options. Either you can export the code to the workspace, it is a temporary exporting thing. Either just export the code or just generate the code with initial parameters. So we will go with this option, just generate the code with initial parameter. So it will what it will do, it will create a matrix.mat file which will keep your all the initialized variable. So just click on OK, then it will just convert these 10 layers into a 10 line of code. Just wait for it. Yeah, it is done. So you can see we have the parameter with the name param to 2021-0403 dot mat, and these are the things. This is the layer, the 10 layers, and that input images is customized to 90 cross 90 into 3, and the fully connected layer here you can see 10, but since we have only 3 classes, we have to just change it to 3, and the rest thing will remain the same. So we are done with the this part, feature extraction part. Now you have to write the code to read the input images and to classify and test the accuracy of the classes. So what I have done, I will not save this part because I have done everything for you. So this part is something that will read the images, and for classification task you have to use image data store. Here you have to provide the foldering where you have to keep all the classes. So let me go there. In ES338 there is a folder called train CNN, and in that train CNN we have this code CNN example, that is CNN example with the parameter, and we have 3 different subfolder: built up, open land, and vegetation. In built up we have 10 images of 90 cross 90. In open land we have 10 images. In vegetation we have 10 images. And what we have done, we have used the split each label with 80% data for training and remaining 20% data for testing. So you can use this command, and that too in randomized fashion. Means suppose we have provided an image b1, b2, b3 up to b10. It will shuffle every data and randomly select 8 data out of 10 for training the and CNN from each classes, from 8 from built up, 8 from open land, and 8 from vegetation, and it will evaluate the performance on the remaining two images of each classes. So this is the first thing. Means we have prepared the training data. Means we have just divided the data in 80:20 ratio: 80 for training, 20 for validation or testing. And this is the layer part that has been already explained. And now coming down, what we have to do, we have to explain everything: which training option you are using, what is the epoch, what is the batch size, what is the learning rate, what is the drop off factor. These are some technical jargons are there. Means you don't worry about these terms. I will discuss some of these things. What are iteration, what are learning rate, in ANN, what is batch size, what is epoch, what is iteration, that I will tell you later. So just ignore that part, and we have used the train network command, and in that we have to pass the training data, the layer, and that the training option through which you are training the model, and the net will contain the train network. So let me once you run this part, so you have a train network. So what I have done, apart from these images built up open land and vegetation, let me show you. Apart from these images, I have selected some random test images. uh, yeah, one test images is of built up, one test images is for test B is test built up, test O is test open land, test V is test vegetation. So these are the images that are not present in the training images. So we will provide these images and try to figure out whether our trained model is going to classify the things correctly or not. So let us do. Let me just expand the thing so that it get clearly visible to you. So before that, let me run the thing in section wise. Let me run this section. After that, let separate the data in 80 to 10:20 ratio. Yeah, you can see the simultaneously your workspace is updating. Let me load the layers by clicking on the run section. You can plot the layers. It has been already plotted here. Just load the training option and train the network. So what it will do, it will train the data, train your CNN model with 80% data and show you the performance with the remaining 20% data. So for the understanding purpose, I have selected only 10 images for each classes. What you are supposed to do, you are just take more images, take 50 images of each classes and increase the number of classes to have a clear picture of the CNN and to have the clear idea of the accuracy. So you can see the y-axis is your accuracy axis and the x-axis is iteration. So it is showing you the accuracy based upon the remaining 20% data. And the simultaneously it is also plotting the loss. So here you can see it achieved 100% accuracy, and here you can see the loss becomes 0, and lastly it increases slightly. Okay, so once we are done, just close this part and evaluate the means the train network with the test images, that test B, test 2 and test V. For that I have just provided the directory test 2, means we are providing the open land images, and let us see whether it is classifying the things correctly or not. Let me run this part. It is already run, I guess. Yeah, so you can see it correctly classify as a open land. Let me change to built up, and now it is now classifying built up as a open land. So, and let me check with your vegetation. It is classifying vegetation correctly. So what you have to do, we have to play with that training option to get the correct result. For 100% accuracy, just increase the maximum epoch size and run the complete thing in one go and wait for the result. What is epoch? Epoch is the forward and backward pass of all the training data. So I will discuss it after I will discuss the regression part. So this time also we are unable to take means reach to the accuracy of 100%. So you have to just play around with these things so that at the end you get a correct result. Let me check once more whether it is classifying built up correctly or not. Yeah, now you can see it just classify the built up as a built up. Earlier it is classifying built up as an open line. So what this score is representing, this is nothing but this part, that is soft activation function. So here you can see that it is 20, the model suggests 20, it is 20% horse. This image is 20% horse image, 70% zebra and 10% dog. But in our case, since we have very small number of training images, it's suggesting directly that it is 100% built up. So these are the things that you can do. You can just play around it, and I have already told you how. Suppose I in if I have given you a task that instead of these images, that RGB images, just use the Landsat 8 images. Then what you will do, you will define the size, and just if you are interested in taking the composite image of 5 bands, then change this to 5. After that you are done. And if you are increasing the number of classes, then don't forget to change here the fully connected layer number of outputs. So this is the things that how you are going to use CNN for classification. And for regression, you have to do a slight change. For regression purpose, just you need to delete these 2 layers and put a regression layer here. And just export the thing similarly that we have done earlier for the classification task. So I have also done it for you. Let me go there. Sorry. So how classification is different from regression? Here what we are doing, there are some 2 or 3 points that you need to remember for using CNN for regression, is that you can't use image data store command that we have used earlier for your classification task. In this case, you have to read the images by providing the path and creating a cell of that path and provide the corresponding value. So what we have done for here, suppose I have just vaguely assigned some number to some weight or some number to these corresponding vegetation images. So in regression problem, what we have, Suppose I have given you a task that you have the NDVI image. So you have the image, and the average value of NDVI over all the pixel is suppose 0.4. So this way you will train your regression model that for image 1 it is 0.4, for image 2 it is 0.3, and after training with several images you need to just put a new image, a completely new image, and you can expect the CNN to predict a number for you. So this way, this is first type of regression that I have discussed in the earlier class, that is image to value. Image to value regression. That is, you are training with the image and assigning a value that for this image we have this value, for this image we have this value. So this thing you can do with your Lancet data. So for your understanding purpose, I have just vaguely assigned. Means there is no science in assigning this number. Just to make you comfortable with the regression part also, I have just what I have done. I have just uh, assigned a number 0.1 for vegetation 1 PNG. So what you can do, just create a NDVI of Bhopal region and extract small images and take the average value of the NDVI. Now put the NDVI, train it with the CNN regression model, that for these small NDVI images the average value is this, for this image 2, image 3. So after doing so, you will get to know that when you insert a new image, the CNN will predict the average NDVI over that image, and then you can just match whether it is correctly predicting the thing or not. So one uh, correction is that you can't use that image data store command. You have to just create a cell of the images for regression task. And the second point is that you can't use split each label for separating the data as training and test set. Instead, what you can do, you have to use CV partition for regression problem, and you have to create a table of containing a cell of the path of the images and the corresponding values. So here I have selected 9 images, V1, V2, V3 is missing, and similarly for all the 9 images I have assigned 9 values in vector called value, and just created a table and just pass this table to CV partition, and it will randomly hold out 70% data for the training and 30% data for the your validation. So if you run this thing, the layer part is same as previous, the training option is same, and we will now pass a test V images to check whether what value it is predicting for us. So let us run it. In case of classification, you notice that it is plotting the thing between accuracy and iteration, but in case of regression it will plot the thing between root mean square error and iteration. So let us wait. You can see that earlier the RMSE is very high, since our range of input is range of value is from 0 to 1. So having a RMSE of 50 for that is very high. But the last RMSE that we get is 0.18, which is a kind of acceptable thing. Since why we are getting this much of RMSE is that we have just assigned the value vaguely. We don't have followed anything. So this is completely for your understanding purpose. So let me close this part and let us see what value it has assigned to the test image. So you can see for the test v images, it have assigned a value of 0.0321, and this thing means in round figure, if you talk, it is 0.03. So this way you can do the regression task. And the last thing is how you can perform image to image regression. That I will share a blog with you in the Google Classroom. Just go through the blog. It completely explains the things in a very layman language. So these are the complete thing that I have uh, interested in this lecture. Means I have prepared for this lecture, and let me complete the session by explaining you the difference between a epoch, a batch size, and one iteration. So let me use the whiteboard for it. So what epoch means? Epoch is something, is a combination. An epoch is a combination of your iteration. Means it may be x time iteration. So how you will decide the x? So let me tell you. Suppose but if you define epoch scientifically, then it is one forward and one backward pass of the training data. Just remember, one forward and one backward pass of all the training data, all the data, all the training data. And batch, what do you mean by batch size? Batch size is the number of training example in one forward and one backward pass. So with this definition, the number of iteration is just the number of passes. So if you can visualize the thing that if you have 5500 k number of training data, that is the number of training data, and it has been given that the batch size is your 1000, then you can calculate that in one epoch you will have 55000 divided by 1000. You can cancel out these things. It comes out to be 55 iteration. So people get confused with the term epoch and iteration. They consider it as the same thing, but it's not same thing. It is completely related to the batch size. So what is your batch size? Based upon that, you will get to know whether your epoch and iteration is same or not. Means if you have a batch size of 1, then in that case only the number of epoch is equal to number of iteration. So I hope I have delivered the thing to you. In case of any doubt, just write to me, or you can come to the lab. So I hope you can now use CNN model, train it, and if you are interested, then I can share the code with you. And just focus it carefully. That means you can't get the code of CNN for training your own data on internet also. So just if I have invested some time to you for you, then I am expecting that you can do a much higher version from the learning. So what I can expect from you, just do anything. Means I will prefer. I mean, I will recommend you to use satellite images, but it is just not put you means just not limit yourself to the remote sensing data. You can do anything. What you can do instead of built up open land and your uh, vegetation, what you can do, you can use your own family members photo, 10 photos of each family member. Suppose there are 5 members, then you can train that through, I mean, you can train the CNN model for the facial extraction. And in that case you may have to increase the number of feature extraction, because extracting means classifying images or facial images is very typical. So for that the number of features should be high. In that case you have to increase this number of uh, layers in the feature extraction process, and just provide a new image of your family members, means and let the CNN decide what it will be. So that's all for this class. Thank you so much.